will record. I will record and upload this to the LMS. Okay, no issue. I have already recorded, no? Yeah. Okay, so I will start. Okay. Otherwise, we are running out of time. So let me start. Okay. I will start. You can hear me, no? No issue, no? Okay, I am sharing my screen. Okay. Can you see my screen? Can you see my screen? Okay, thank you. So actually, this is the MATLAB default screen. Okay. So when you open the MATLAB, you will get this kind of a screen. Sometime maybe like this. Okay. Maybe like this. Okay. So you have a workspace here, and you have a command window. Okay. So the one option is that we can type the command here one by one. Okay. For example, if you want to add two numbers, okay, like a +2, you have to put this semicolon, okay, and b is equal to 3 semicolon, okay. Then you can get any value. Maybe let's take a plus b, okay. So you can get the answer like this, okay. So one way is that you can write the command in this command window and run one by one, okay. Then you can get the program achieved, okay. But I prefer to normally I don't like to go through this method, okay. Because if some error is there, it is hard to rectify, okay. So normally I write my program as a script, okay. So you can use this, you can see here the new script tab is there, no? Okay. So if you click that, you will get the document, okay. So here you can write the script, okay. So here you can write the same thing, okay, like this. So here you can, there we have write like this in the command prompt. So here also you can type the things, okay. So you have to put it to another variable like this, okay. Then you can run this, okay. Then you can run this, no problem, okay. Then you have to save it, okay. Okay. Let's save with 6 is SIG and system 1. Sorry, this is for DSP, no? DSP1. Okay. Then you can write. Then you will get the answer here. Okay, in Workspace you can get the answer. Okay. So here you can see C is there. So this C is the variable, and you can see the answer here in the Workspace. Okay. So likewise, you can write the MATLAB command in as a script. Then you can run using this run button. Okay. So we will do that way. Okay. Rather than typing in that command window, we will go through this method. Okay. We will write the script first, then we will run the program. Okay. Okay, so now we will start the MATLAB with the signal and system stuff. Okay, this is some kind of a jumpy start. Okay, we are not going through the basic things. Actually, those are not necessary. Okay, because in MATLAB, you know that when you are using other computer language, you have to sometime know the variable types. Okay, this variable type should be a float, the integer likewise. Okay, string, like this. Okay, but in MATLAB normally we no need to specify the variable type. Okay, it is a float type, string type, so we no need to define it first. Okay, we can continue as we wish. Okay, so if I go to my normal window, okay, so I think you can see my journal window. Okay, so you know that in DSP we are normally normally deal with continuous time and discrete time signal, no? Continuous time and discrete time signal. Okay. Actually, most probably we are focusing on discrete time signal in DSP. Okay. So normally in signal and system, we are dealing with the continuous time signal. Now we mainly in DSP, you are mainly discussing discrete time signal. Okay. But before you you have not done the MATLAB in signal and system, so we will do the both cases, okay, for continuous and discrete time signals. Okay. So other thing is, I think you have learned that another type of signal, that is random signal and deterministic signal. No? Okay. So this random means there is uncertainty. No, it is not certain. There is uncertainty. Okay. That means time to time, the property can be changed. Okay. But for the deterministic signal, it is there is no uncertainty. Okay. So the properties are not changing the properties. Okay. Not changing the properties. Okay. So I think most probably in DSP you are dealing with the deterministic signal. You are not going to deal with the random signals. No. Okay, you are not going to deal with random signals. Okay, in the random signals, normally the properties are changing, so you have to use statistical approach to analyze this random signal. You have to get the expected value, okay, and maybe the autocorrelation, okay, autocorrelation, maybe cross correlation, okay, covariance. So you have to go through these kind of terms when you are analyzing random signals. Okay. So in DSP also, normally we are analyzing deterministic signal. No? Okay. Deterministic signal means the properties are not changing. For example, if we get a sinusoidal signal like this, okay, a cos 25 ft plus 5 or something. Okay, so this is a sinusoidal signal, standard sinusoidal signal, and this is a continuous time signal. Okay, I get the continuous time signal. Okay, so you know that in deterministic case, you can analyze, you can interpret the signal through this closed form expression. Okay, so there are some closed form expression for the deterministic signal. So we can use that expression to interpret the signal completely. Okay, so here also we are going to focus our attention only on deterministic signal. Okay, what I want to tell you is that you can do any analysis using this equation. Okay, related to the signal. Okay, deterministic signal means if I couldn't understand what you have told, subject quiz means let me check. You means in the document I have sent you, no? You are talking about the LMS, no? Yeah, LMS, I think there are some problem actually. I don't do any modification for the LMS. Okay, I got the complaint from the lateral student also. Anyway, I will do now. I think the quiz. Okay, no. Yeah, maybe some mechanical stops are there, no. Yeah. Okay, I will do it. Okay, I will do it. Don't try that quiz. Okay. I I think some student has done the quiz. Okay. When I go to the LMS page, I have got the same complaint from the lateral entry student. So I visit the LMS page. Then I saw that one or two student has attempted. They have completed that mechanical question. Okay. So I will change it. I hope I have already changed it. Okay. Anyway, maybe there is a problem. Anyway, I will do. Okay, no issue. Okay. Now let us focus on this session. Okay. I will do that tracking. Okay, I will try. Okay, I will try. Okay, okay. I will do it. Okay. Okay, so let's start our session. Okay, let's start the session. So now we are in deterministic signal. These are the main property of the signal. You know that amplitude, frequency, and phase. Yeah. Anyone want to talk? Okay. So so in deterministic signal, these are constant. These are constant, not changing. Okay. But in a random case, this amplitude, frequency, and phase can be changed according to some distribution, maybe according to the Gaussian distribution, maybe according to the binomial distribution or Poisson distribution. So these properties can be changed according to a distribution. Okay, so those are normally random signals. But if these properties are not changing, we call this deterministic signal. So here we are mainly focused on deterministic signal, and in both continuous and discrete case. Okay, and you also know that in deterministic case, we can do the analysis using this expression for the signal. Okay. Okay, let's move to the MATLAB again. Okay. Okay, so I will. So this is our. So I think you can see this screen also. Okay. So. So this is your tutorial. Okay, these are the activities you have to done. Okay, we will try to do yeah, you can go, no issue. Okay, then I will upload the session, then you can take that. Okay, you can refer the note. Okay. Okay, I will continue, but you can leave. Okay, no problem. Then I will upload. Then you can see. Okay, so here you have to generate a sinusoidal function in MATLAB. Okay, so here the sinusoidal signal is given. Okay, signal is given, and you are given some properties. Okay, so altogether three graph you have to three signals you have to plot. Okay, so we will see how to plot. Okay, so it is very easy. Okay, so first normally I before starting, okay, I will use this two command. Okay, so why I use this command is that you can see that this answer is from our first program. No, it is in the workplace. Then we have write another program to add 2 plus 2. Then the answer is also there. But you can see that these first answers are not deleted. Okay, so when you are running the program, all variables and the values will be saved in the workplace. Okay, so if I run this, okay, so you can see that the workspace is clear, no? So actually this command is for clear the workplace. Okay, so this command is for clear the workplace. Okay, so why we clear the workplace? Because, okay, sorry, if you put this mark, sorry, if you put so this should be as a comment. Okay, so I will comment it. Okay, not this. Okay, I will comment this. So I just right click on the words. Okay, then I comment. I put the comment. Then it is as a comment. So it is not engaging with the yeah, I have already sent the question sheet. Okay, I will send it again. You means this MATLAB question sheet, no? MATLAB activity. Okay, I will send it again. Okay, I have sent. You can download it now. Please download. Okay. Yeah, I will also upload it to the LMS. Okay. So now this command is for clear the workspace. Okay, this workspace. Okay, workspace actually. Sorry, not it is workplace. It is workspace. No, this is for clear the workspace. Okay, so you can see that I have cleared the workspace. Okay, why I have cleared the workspace? If the previous programs variables are there, sometime it will affect to our new program. Okay, so it is very important to clear the workspace. Okay, so please use this command at the start of the script. Okay, then you can clear the workspace. Okay, so now we have cleared the workspace. Okay, then we can write that signal. Okay, so what is the signal? It is a sine signal. I will plot it like this. It is x t. I will write like this. X t is equal to it is a. Okay, capital A. So you have to use this operator. So this is the multiplier operator. Okay, in MATLAB you have many operators. Okay, star is for multiplication. Okay, this is for multiplication. Okay, and just plus is for addition, minus is for subtraction. Okay, and this slash is for division. Okay, this is for division, and we have other operators also, Boolean operators like that, but now we are not going to do. Okay, so we have only these we are using only these four operators right now. Okay, multiplication, addition, subtraction, and division. Okay, So you have to use that operator, otherwise it will not get as a multiplication. Okay, so I can write the sign here. Please wait. Hello. Okay, so I can type, so you can directly type this sign here. Okay, so MATLAB can read it as a sign. Okay, so sign, here we have 2, then you have to use this multiplication operator. 5 means you have to write it like this, pi. Okay, so in MATLAB the pi will write like this. Okay, pi, py. Okay, pi f t plus a space, no, this. Okay, so this is the equation for our signals, no, for our signal this is the equation. So if I go through to the tutorial again, I have write this equation. Okay, so instead of this 5 pi we use pi, so this 5 I use just p. Okay, so you can use any number. Okay, so another thing is this MATLAB is case sensitive. Okay, so you have to uh, MATLAB is case sensitive. Okay, so you have to remember this is capital P and this is capital A, so you have to put some value there. Okay, otherwise there is no values to run the program. Okay, so it is case sensitive and you have to keep remember that one also. Okay, so now this is our equation. Okay, so when we are plotting a signal, normally what is the procedure? The procedure is that, okay, so it is the normal procedure. So you have this signal. Okay, you have this signal xt a sine 25ft plus p. Okay, so you have the signal. So how you write the signal? So this is your independent variable. No, this t is your independent variable. So normally you put some value to the independent variable, maybe 1 2 3 4 5 6, like so on. Then you calculate the corresponding xt value, no, signal value, amplitude value. So you calculate corresponding this value x3, x4, like that. Okay, then you normally put the graph. Okay, this is your independent variable and this is your dependent variable. Okay, so you have marked this value here, then you mark the corresponding value like this. Okay, then you can join that mark, that points. Okay, actually MATLAB also will do the same thing. Okay, so it will do the same thing. Okay, so we will see. Okay, so you can see that here you have to define this t first. Okay, this is because this is the independent variable. Okay, so you have to define that t. Okay, before the signals you have to define this t. Okay, so I will define it like this. Okay, so you can see that. So can you tell me this t should be one value or the collection of value? This t should be a one value or the collection of value? Please feedback. Is this the one value or is it a collection of value? Yeah, it is a collection of value. Okay. Normally, if the collection of value, we normally use a name for that. What is that? Can you remember? What is that? So in T, okay. So T like this, no? It has some value 1, 2, 3, 4, 5, 6, likewise. Okay. So what is this called? In programming, what is this called? Not in programming. In mathematics and programming, what is this called? Yeah, it is a series. We can say it is a series. These are variables also. Yeah, series of data. Yes, but we normally called it array. No, can you remember? It is array. No. Okay, so it is array. Actually, series of collection of data, collection of variable. Okay, but normally it is referred as array. Okay, so this T is array. Okay. Okay. So also we can see that this is a matrix. Okay, one row matrix. This is we can interpret as row matrix. Okay, this is also interpreted as a row matrix because one row is there. If it is like this, okay, if the T is like this, we can see this is a column matrix. Okay, so now it is a row matrix. Okay, so in MATLAB you can define a matrix, a row matrix or column matrix or array like this. Okay, so you can put the starting and end value here. So let's say T is starting from 0 and the T is n from 10, let's say from 10. Okay, and you have to also, you can also define the step. Okay, if you put 1 here like this, okay, like this. Okay, so what it generate? Let's see what it generate after. So I will put this as a comment. Okay, otherwise it will take some, it will give some error message because still we did not give the value to this A, F and P. Okay, so if I run this, so you can see that this is a 1 by 11. So if you double click here, so you will have another window here, variable window. Okay, so you can see that we can see the variable here. So there are 11 variable. 1 by 11 means this is one row, 11 column. Okay, so actually this T is defined as a matrix. Okay, 1 by 11 matrix as a row matrix. Okay, so this is 1 by 11. So you can see the value here, 0 to 10, because 0 is included there. So 11 items are there. So it is 1 by 11 matrix, no? One row and 11 column. Okay, so these are the data. Okay, so you can see that it is 0, 1, 2, 3 like that. So if you put here 0.5, 0.5, what it will look like. Okay, so you will get 0.5 step. So you will get 0, 0 0.5, 1, 1.5, 2 like this. So let's see. Yeah, you can see it. No, now you have 21 values, 21 values. Okay. Okay. So now the increment is 0.5, 0, 0.5, 1, 1.5. So this middle number will define the increment. Okay. So to plot this signal, we have to give some value to this A. This pi is a value. Okay, pi, no, this is a pi, the value is there. Okay, so we have to give the values to A, F and P, amplitude, frequency and for the phase. Okay, so we can define it here like this. So A is equal to, let's say it is 2 volt or something. Okay, and F let's say it is 50 hertz, okay, 50 hertz or something. Then P, phase, it is equal to, let's say it is pi by 2, okay. So we have defined the other properties also. So I think now you can plot this value, okay. So if I run, yeah, we have undefined function no variable p, okay, because okay, what is the problem? Can you anyone tell what is the problem here? Can anyone tell? So I have error message, okay. So error message is at the command window. You can see that the error is in this statement, okay. And what is the error? Actually, it is said that this p is not defined. Why it is like that? Anyone can answer? Yeah, 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 thank you. Okay, so that is the problem, okay, because this is case sensitive, so you have to put the capital P here, because we have put the simple capital P here, but here I have typed the simple P, so that this P is not defined, no. So you can run this, then you can see that the T is there, okay, and next T is there, and for the T, so T values are there, okay. So these are the T value, and XT values are also there. These are the XT value. So what the MATLAB has done, it so here you have a T array, okay. So it take one by one this number, okay, one by one value, and substitute this to this statement and calculate the xt value, okay. So it automatically generate another array, no. It is also in the same dimension, because this xt, he calculated this xt according to these t values, okay. So there are now 21 t values, okay, 21 t values. So xt also should have 21 values, no? So you can see both are in same dimension, okay? So now you can plot, okay? So at the beginning, I have told you that, okay, now this, so now we have put some 0, 1, 2, 3, 4 for t value, and the value is calculated like this, no, calculated like this, okay, but still it not shown, okay, it is still not shown, okay, because we didn't give the command to show this graph, okay, but now the values are calculated. Now only thing is that we have is that to draw, no. Okay, so to draw, you can use two commands, okay. One command is called stem, other command is called plot, okay. So what is this stem? Stem means if you give this command, it will show only this value, only the calculated value, like this, okay. Okay, so let's give the stem value, okay. So I type stem, okay, stem, okay. So you can see that stem xy, so x is the independent variable, y is the dependent variable in default, no. So here our independent variable is t, so I put it as t, okay, and our dependent variable is xt, no, x underscore t. So if I run this, so you can see that some values are calculated, and just these are the values, okay. So in all the values are 2, Okay, so all the values are 2 actually here. So if you're going to this xt, you can see that all the values are 2. Okay, there is no any change. Okay, okay, so this is the stem. Okay, so if you use this plot command, so what is the system actually? Okay, so using the stem command, you can see that which type of signals you can draw. So using stem, you can draw discrete time signal. No, discrete time signal is look like, no, because you have discrete value like this. Okay, discrete value like this. Okay, so to plot discrete value signal, you can use this stem command. Okay, please remember that one. Okay, to plot discrete time signal, you can use this stem command. Okay, and if you use this plot command, it will just join this point. It will just join this point. Okay, so it will look like a continuous time signal. So this plot command can be used to draw continuous time signal. Okay, stem can be used for the discrete time case. Plot can be used the continuous time case. So if I put the plot here, okay, if I use the plot here, okay, so it here also the independent variable is t and the dependent variable is x underscore t. Okay, so you can see that to draw it in one graph, you have to type the hold on command. Okay, so this is another statement. Okay, if you draw 2 or 3 graph in one coordination in one sheet, okay, you have to use this one. Otherwise, this one when it run, okay, only this one will appear. Okay, this one will cut and this one will appear, not both. Okay, to show the both, you have to write hold on. Okay, let me define value color for this two. Okay, so I will use here red color, so you can use this comma and type R and another comma. So this is the color. So I have defined the color for this plot. Okay, and I have defined another color for this plot. Okay, so here is stem plot. I have defined red color. I just put R, okay, within the bracket, and I have put green within the bracket. Okay, so you can see that this red color is the stem command. So you have some values, discrete value, and this green color is the plot command. So you can see that all the calculated value are joined. Okay, all the calculated value are joined. So you can see this green color one. Okay, so I hope you can understand what the stem is doing and what is the plot is doing. Okay, okay, so if you need to actually this stem in plot, so you can define the weight of this the thickness of this line. Okay, so many variables you can define. Okay, so we don't have time to discuss all the things. Okay, so if you need any help, okay, so you can go to the internet. Okay, Actually, I also do the same thing. I normally, I can't remember anything. Each command in MATLAB, normally I use Google to search the command. Okay. Once you understand how the MATLAB is going, so you no need to, I think one mic is on, I will mute it. Okay. Okay. I mute it. Okay. So now it is okay now. Okay. So you can use the Google. Okay. So you can use this, let's say the plot command in MATLAB. Okay. So you can type like this. Okay. In MathWork, so you can see this MathWork, web. Okay. So you can go to the MathWork web, and you can find all the details there. Oh, short English. Okay. So you can see all the related things, all the related. The language is changing. So don't go to this. This is the default website. Okay, official website. I can't. Anyway, in my laptop, always this Chinese web is on. Okay, but I don't think when you are opening this MathWork website, it is normally by default it is in English. Okay, so you can read this. Okay, so anyway, you can see all the details related with the plot command is there. Okay, and also you can see some example also. Okay, so I think you can understand. If you need more information about this plot command, you can visit this website. Okay. 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 So anyway, now I think you have idea about what is system and what is plot. Okay. Okay, please keep that idea. Okay. Now the problem is that still it is not a sine wave. No. So this plot is not a sine wave. So can anyone tell what is the problems there? What is the problem actually? So you can see that this is not a sine wave. No. So this green color should be a plot. So it should be like this. No. Like it should be like a sine wave, but here we don't see a sine wave. It is just a line. Okay. So what is the problem? Can anyone tell? I think rather than typing, if you can talk, it is better. Because typing is hard, no? It will take some time. If your answer is wrong, it is okay. No issue. Okay, the problem is that here, this plot, I said that this plot is for continuous. No, it is for continuous time signals. Okay, so you know that in continuous time signals, there is no separation between the two numbers. Okay, because if we get two duration, any duration like this, okay, within this duration in continuous time, all the values are there. No, very small values are there. Okay, but in discrete time it is not like that. Okay, so MATLAB can't generate Okay, MATLAB can't generate continuous variable, continuous time variable. MATLAB can't generate. So what you have to do is you can generate discrete value. Okay, you can generate discrete time value, discrete variable. You can't generate continuous variable. You can generate discrete variable. If you get very close point, okay, like 0, 0, 1, 0.002, like this, and if you plot this, then you will get some very close point here. And if you use the plot command, so it will look like a continuous variable, continuous graph. Okay, so that is the thing we have to do. Okay, I hope you can understand. Okay, so here what I need to do is I have to reduce the separation. Let's take like this. Okay, then if I write this, okay, so it will take some time. So you can see that now there are many variables, so you can see anything. Okay, so that means here very close lines are there. So you can see it is completely green. Okay, so what you have to do is, if you reduce this value, okay, if you reduce this value, let's take it for 2. Okay, still you can't see, no, still you can't see, but now it is some, you can see some graph are there, but still it can't see. Let's take it is 1, still we can't see. Let's take 0.2 or something. Now you can see, no, now you can see very small, just like a sine wave, no? Okay, so if you use 0.1, okay, so let's take 0.06 up to here. Okay, 0.06. Okay, now you can see a sine wave, no? You can see a sine wave here. Okay, so anyway, if I remove this stem command, okay, if I remove this stem command, you can see a nice sine wave, I hope. Okay, so I will comment it. Okay, now the stem command is not there. Okay, so let's see what we can see. Okay, so you can see now it is a sine wave, no? So if the stem is there, it is just calculating very near points and put that line like this. Okay, then you can see a red fill here. Okay, now you can see a fine sine wave. So this is the way to plot the sine wave. Okay, so I think now you can do the first one. Okay, now you can do this first one. Okay, now let's go to the second one. Okay, so this is related with sampling actually. Okay, so actually now I hope you can plot any continuous graph. Okay, and another one is, I should tell you that here we put the value for this A, F, and P. Okay, but in tutorial you have different value. Okay, so sometime you may feel that can we define a variable and can we input it? Okay, so normally in Pascal and other language you are doing the same things, and MATLAB also you can do the same thing, but as usual I can't remember the command. Okay, so normally I am using MATLAB, sorry, I am using the Google to find it. Okay, so let me type input user variable in MATLAB, okay, request user. So this input, okay, so you can use this input, okay, input command. If I so this is the input command, okay, so you can use that input, okay. So here you can write, so you can see this value, okay. So see this example, so you can write it like this, okay, write it like this. So let's take, okay, so instead of this a, I can type like this, okay, as a variable. So I put a, okay, input, okay, input, okay, and we have to use this prompt, okay, prompt means it is prompt in here, okay, so the value is prompt in here. So I prompt the amplitude, let's say it is amplitude, so within comma I write like this, amplitude, okay. So it should be like this, okay. So this is the string, okay, so this amplitude is the string. When you run this, you will see this amplitude in maybe in the command window, okay. So then you have to input the value for that amplitude, then that value will take as a, okay. So here I comment this a, okay, then I run this. What is the undefined variable prompt? Prompt, yes, may I what is the issue? P is there, no? Sorry, thank you, okay. So this is P, no? Yeah, what is the issue? PROMPT, PROMPT. So I think we no need to this prompt, okay. So I can write this, okay, then it is okay. So that prompt is just highlight to the things that we want to prompt here, okay. So we can write like this, okay, input, then you can put a bracket, okay. If you need something to prompt here, you can just add is it within the comma, okay, within the upper comma, okay. So you can see the amplitude, then I can input 2 here, okay, then it is running, no, okay. Yeah, I can send. I will send my contact details. So this is my contact details. So you can contact me, okay. And also I have a WhatsApp message, WhatsApp number, okay. WhatsApp 0718644612. Okay, this is my WhatsApp number, okay. So you can contact me through this number, okay. So I think you can now understand. So this F and P also you can write like this, okay. So I will remove this one because every time I have to put the variable here, okay. So it will be again time consuming. So I will give this. Okay. Okay. Now we move to the second one. Okay. Now we move to the second question. Okay. Second activity. So we have to sample a signal and plot it. Okay. So we have to sample the signal and plot it. So I think you may have learned the sampling. Okay. You may have learned the sampling. No need to submit. Okay. No need to submit, but you will get sometime assignment. Okay. Very small assignment. Sometime if the time is not the issue. Actually, it is decided by Dr. Udesh, not me. Okay. Sometime you may have to submit a assignment, very simple assignment. Okay. But this one no need up to now. Okay. Still no need. Okay. But when you are going for a higher education, this knowledge will be very important. Okay. So please go through this lesson and try to understand this MATLAB session. Okay. So I will I will quickly, yeah, I will definitely I will upload the session. Okay. So so now we will move to the sampling. Okay, we will move to the sampling. So we know, I think, yeah, sure. Rifki, I think I have already removed the unnecessary quiz and stuff. Actually, Dr. Udesh asked me to do so. So I think I have already done. It's still there, no? Okay, maybe an issue. I will check it. I will check it definitely. Okay. Anyway, if you need any help for your learning stuff, okay, if you need to do some question tutorial regarding in what you have learned up to now, I can arrange a tutorial session for that. Okay, if you have any problem with the questions and other things you have learned up to now, you can inform to Dr. Udesh, or you can inform directly me, then I can arrange a tutorial session. Okay. Okay, so we will move to this one. Okay, now we are going to do the sampling. Okay, sampling. So I think in signal and system one also you have learned the sampling. Okay, so there we are using what is called impulse sampling. No, we have learned this impulse sampling. Okay, and one question, can you remember here I have select very small time duration to see the graph, to see the signal very well. Okay, can you remember that one thing you have learned, how to extend and how to shrink the signal using one time manipulating technique? Can you remember that one? That is time scaling. No, can you remember the time manipulating that, or time transformation technique? So here also we are doing the same thing. Okay, in oscilloscope also you are doing that time scaling things to see the signal very well in the screen. Okay, so time scaling is not changing the frequency. Okay, so we are using time scale in time to expand or shrink the signal. Okay, but frequency is not changing. Okay. Here also, if I use a very big time duration, you can see very near cycles are there. But if I use very small duration, so you can see that we can see some nice circle. Okay, the expand circle. This is actually time scaling. No any frequency change in no other things. Okay, in oscilloscope also we have do the same thing. Okay, so it is time scaling. Okay. Okay, now we will come to this one, sampling. Okay, impulse sampling. Okay, so normally we are doing this impulse sampling. Actually, this is a theoretical approach. We can't practically achieve this impulse sampling. Okay, this is not practical scenario. I think you can use MATLAB to draw it. Okay, it is okay because I have given the marks. Those who have plot it in the MATLAB also. Okay, so you can plot it in MATLAB and also you can plot it by hand. Okay, no issue. Because there is a advantage you have to get by learning this stuff. No, otherwise it is not used. If you are going to draw the signal by your hand, there is no need to learn this MATLAB stuff. No. Okay, so you can use the MATLAB. Okay. Okay, so this is impulse sampling. Okay. Maybe the deadline can be extend. Okay, maybe extend. I hope. Okay. I will talk it with Dr. Udesh. Okay, and I will let you know. So this is impulse sampling. Okay, so this is not a practical scenario. Okay, so what is the concept is that if you have a signal like this, okay, you send this signal through some kind of a switch. Okay, so this switch can be implement using a transistor or something electronically. Okay. I can't understand. So if so, can you? I think you have many questions. Okay, so please contact me after this session. Okay, then I can help you. I think I maybe help you. Okay, so you can just because something I couldn't understand. Okay, so I think it is better if you can talk me after this session. Then we can finalize the things. Okay, Rifki. Okay. Otherwise, now the time is very critical. Okay, we have to try to complete this one also, at least this one. Okay, so let me start the session. Okay, so this is so in sampling we are doing like this. Okay, so when you close this switch, you can you can have a voltage here. Okay, then you open it. Okay, then again close it, then you can have another voltage like this, then you can get some voltage like this. Okay, actually this is the sampling. Okay, you turn on and turn off the switch. Okay, so this is called impulse sampling because this switch off is very small. The off status of duration is very small and it is near to zero. So it is just like an impulse like this. Okay, like this. Okay, so within this impulse you will get this voltage value of this signal. Okay, these are the voltage value. No, this is a voltage or current variation. Okay, actually if I fairly talk, it is the amplitude. some amplitudes levels are there. This is the amplitude level. Okay, these are the amplitudes level. Okay, but when we are sampling the electronic signal, we are normally we are getting the voltage signal and we sample the voltage in case of electrical. Okay. Okay, Rifki, you can leave, no issue. So you can contact me after the session. Okay. So this is the sampling. Okay, and you can see that, you know that this off and on, this there is some, so if you on again, you will get another time, no? Okay, so this is the first on the switch, this is the, then you again off the switch, after some time duration you again on the switch. Okay, so this duration we called sampling time, no? This duration we called sampling time. So I think you have already learned these things, so I'm not going to explain this anymore. Okay, further, this is a quick recap. Okay, so this is the sampling time. Okay, and this is also a sampling time. Okay, so you can see, I think you know that we have uniform sampling and non-uniform sampling. In uniform sampling, this sampling time is constant. Okay, this sampling time is constant because we get the sample at same distance, at the same duration, that is uniform sampling. Okay, so normally practically we are using uniform sampling for simplicity and efficiency. Okay, so this uniform sampling is the more efficient one. So normally we take that one practically. Okay, so so this sampling time is a constant. Let's say it is Ts. Okay, so this is the sampling time. Okay, and you also know that when you plot the DC signal, discrete signal, okay, you plot like this, no? It is like this. Okay, maybe like this. This is your discrete signal. Okay, and so this is the sampling time. This is the sampling time. Okay, and this is called sample, no? This is called a sample. This point is called sample, n. Okay, it is called n, sample. Okay, I write it again. Okay, so if you have this kind of signal, so you sample it with some duration like this, you get sample like this. Okay, so you get sample like this. Okay, so this is this is your first sample, and this is your second sample, and this is your third sample, this is your fourth sample, like this. So this is the time, the sampling time, Ts. Okay, and this is the sample number. So let's say that this is a 0 sample, this is the first sample, this is the second sample, third sample, fourth sample, fifth sample, like this. So the number of sample we normally denote in n. Okay, so n can be an integer. N should be an integer plus or minus integer. Okay, n is a plus or minus integer. It can be from minus infinity to plus infinity. -3, -2, -1, 0, 1, 2, 3, 4, so on. So this n can be this kind of integer, plus or minus integer. Okay, so how this sample can be minus? Because if you get reference sample like this, if this sample is 0, the before sample referred to this 0, if we get some other previous sample also, so this sample will be minus sample. Okay, so this will be minus sample. This may be -1, this may be -2, -3, -4, so on. So you can have minus and plus sample, but it should be a integer. Okay, so n is a number of sample, that is the integer. So very important is that, okay, very important is that, so you normally refer this n as 1, 2, 3, 4, so on. Okay. So if you draw the signal, like this, okay, in discrete time, okay. So let's say these are the sample. Okay, let's say these are the sample. Okay, so this is our zero sample. This is zero sample. This is first sample. This is second sample. This is third sample. This is 4, 5, 6, 7, 8, 9. Okay, this is same. Okay, so there are some value, no, big 0, 1, 2, 3, 4 values. Okay, but you know that this one should represent a time instant. No, there is a time instant. This is very important one. There is a time instant related to this one, related to this 2, related to this 3, related to this 4. There should be a time instant because this is a time varying signal. This is a time varying signal. Okay. Although we have used n, there should be time instant. Okay. So how we calculate that time instant? I think you know this. Okay. So, so you know this is our sampling time Ts. Okay. And if you want to calculate the time instant this duration, okay, so this is for one sample. Okay, so 1 by Ts, this is the time duration, this is the time instant for this one. Okay, so if you want to get this time instant, it is the length, the time is from here to here, no, from 0 to here. So there are 2 samples, that means it will be 2 by Ts. So here the corresponding time is 3 Ts. Here it will be 4 Ts. Here it will be 5 Ts. So on. No? So in the nth sample, it will be n Ts. Correct? So this is the corresponding time T. Okay. And also I think you can remember that if you have so if you have a signal, let's say like this, to sine 100t or something. Okay, so this is a voltage signal. Let's say this is a voltage signal, and you are asked to sample this signal. Okay, you are asked to sample this signal by let's say with 200 hertz. Okay, 200 hertz or something. Okay, so this is the sampling frequency. This 200 hertz is the sampling frequency. So you know that this is the sampling time. Okay, and 1 by Ts is sampling frequency. Okay, so if you get 1 by Ts, you will get the sampling frequency. Okay, okay, so what you have to do is, let's say it is Fs. Okay, let's say you have to sample this using this sample Fs. Okay, so what you have to do is that T sine 100t, instead of this T, you can put this T is equal to NTS, no? So you can put NTS. Okay, but N by Ts, 1 by Ts is equal to Fs, so Ts equal to 1 by Fs, no? So I will get a common signal. Okay, so I think you can remember, then you will remember the last thing you have learned very well. Okay, so if you have a signal like this, A cos 25 ft, okay, then you are asked to sample this signal using Fs, sampling frequency Fs. Okay, so now you have to convert this to n variable. This T should be converted to n. That is the discrete signal, no? So this is a continuous signal, Yt. Now you have to convert this to Yn, discrete signal. Okay, so what you have to do is, you have this signal A cos 25 ft, but instead of this t, we have to convert, we have to convert this t into n. Okay, so you know that t is equal to nts. So there is the relationship between the t and n. Okay, so what you have to do is, okay, please understand this. I think I am just going very fast, okay, because you have already doing this stuff, you have already done this stuff. Okay, so I am going this is a recap. Okay, so if you have any problem, you can ask. Okay, so you have the relationship. Okay, so you can put that relation instead of t. Okay, now you can see that t is converted into n. That means yt is converted to yn. Yt is a continuous, yn is the discrete. So this n is, you know that it can be minus infinity to plus infinity integer. Minus 1, 0, 1, 2, so on. It is an integer. Okay, so you know that this nts is equal to n by fs, no? N by fs, because ts equal to 1 by fs. So I can write this yn is equal to a cos 25 f by fs n. Okay, so this is my discrete signal, discretized signal. No, this is continuous signal, and this is my discretized signal. Okay, so what is this called actually? This is called nominal frequency. Can you remember? It is normally referred as capital F. Okay, so you can see that if you have continuous time, you have f here, but discrete time, this f is not equal to this f. Okay, actually this f, in the capital F, is the nominalized frequency. That means it is equal to f by fs. It is nominalized by sampling frequency. We called it, it is nominalized by sampling frequency. Okay, so this is the thing you have to keep remember. Okay, let's quickly move to the MATLAB. Okay, please wait another 50 minutes. Okay, then I hope I can complete the sampling at least. Okay, so okay, so now what we have to do? Okay, so let's take this signal. Okay, let's take this signal. Okay, so we will get the same signal here. Okay, now what you have to do is, now let's say you have to you are given sampling frequency. Let's say it is fs. So this is my sampling frequency, fs. Okay, let's say fs is 25 hertz. Okay, so I put fs as 25 hertz. Okay, so now I have to so this is my continuous signal. So if I write my discrete signal, so it will look like this, no? Xn, okay, Xn, and this A is there, okay, sine there, 2, I will copy this. Okay, I will copy this here. It is easy. So I copy the same. I'm going to write the same equation here. Okay, but now instead of this t, I need n. Okay, instead of this t, I need n. Correct? Okay, I need n. Okay, so now now if I plot, so here plot this plot, you will see the in this plot you will see the continuous signal. Now I want to plot the discrete signal also, so I can use this system command. No, okay, so I will remove the system command. Okay, so I use, so the hold on, I will delete here. Okay, now this plot command will plot only the continuous signal. This signal will plot xt. Okay, xt will plot. Now I need to plot the discrete signal also. To plot the discrete signal, what is the command we can use? Please tell me. We have learned it. What is the command we have to use to plot the stem command? Please feedback. What is the command to plot the discrete graph? Right now we have talk. What is the command? Yes, stem. Thank you. Okay, thank you. It is stem. Okay, so I can use stem command. Here it is stem. Okay, now I have to write it in terms of n, no, not t, n, no, using this n, and I should have then the dependent variable is xn, x capital x in x underscore n, correct? Okay, so I will put color, I will put red as usual. Okay, I will put the color red here. So this is now I can plot. Okay, and I also have to write the hold on statement. No, I think if not, we can't see the total graph, two graph in one page. Okay, so so this is now we can plot it, but what is the problem? This is not nominalized, no. So we have to nominalize this. What we have to do is we have to nominalize it. To do the nominalizing, what we have to do? Okay, what we have to do? We have to just divide it. We have to just divide this by TS, no? We have to divide it by TS. Okay, so if I write the nominalized frequency here, if I define it here, so let's say it is capital F. So capital F is equal to F by Fs, no? So we have to put it here. I have to, because after Fs is defined, after I give the value to Fs, I can define the nominalized frequency, that is F. It is equal to F by Fs. Okay. So this is my nominalized frequency. So I have nominalized this. Okay, I have nominalized this. So if I plot, let's plot it. What is the problem? Undefined n, yeah. Still we didn't define the n here. Okay, n should be a integer, no? This n should be an integer. So we have to define the n also. So n, let's say let's put n from 0. So we have to get one increment, no? Other, because n should be a complete number, no? It should be -3, -2, -1, like so on number, no? It should be a complete number. It should be an integer. Okay, so so n should be 0, 1, 2, 3, 4, like that. So I get one increment and I put some value here. Okay, let's say up to 20. That means here I define the number of sample, no? This n is the number of sample. So in this program, I defined 20 sample. Okay, can you understand? So if do you have any problem? Okay, so here the number of sample. Now we have selected 0 to 20 sample. That means 21 sample we get. Now we are trying to plot 21 sample. Let's see what happened. Okay, so if I plot this, okay, if I plot this, so you can see that, okay, so you can see that this red color one are the samples, okay, red color one are the samples. Sorry, this should be capital F, no, this here it should be a nominalized frequency. Can you remember? Okay, so this in discrete signal, it should be capital F, F by Fs, okay. So I put here capital F, okay. So I run this. Let's see what's happened. So you can see that still I can't see any value, okay, because this n is 1, 2, 3 like that. So here I have 1, 2, 3, but my signal is up to 0.6, no, my signal is up to 0.6, okay, but my n is up to 20. So you can see that I can't see any sample in the, because I think you can understand the situation here. I have plot my signal, I have plot my continuous signal up to 0.6, okay, but I have defined the sample at 1, 2, 3, 4 like that. So the sample will like here, will lay here, but I can't, the signal is not running here, no, because I have stopped the signal here, okay. So that is what we can see as a green value, okay. So the signal is very small compared to this value, okay, compared to this value. Can you understand what I'm talking? No, I think you can understand. So these are the things actually we actually face in MATLAB, okay. So we have to find the solution for that one. There are not much command, okay. You have to use your practice to overcome the problems, okay. So you can see that we have defined the signal up to 0.6, okay, but the samples is at 1, 2, 3, 4 like this, okay, like this, okay. So if it is t here, okay, so you can see that compared to this value, compared to this total value, because I have selecting 20 sample. So this line, this x-axis, t-axis will go to the 20, no, up to 20, 6, 7, 8, 9, up to 20. So this is very big one, and this point is very small, 0.06. That is why we can see just like a very small graph here, and other samples are there, okay. So what you have to do is actually, okay, the first thing is that I believe that this n is just a number, no, this n is just a number, 1, 2, 3, 4 number, but we have related it with the time, okay, we have related it with the time. So let me think that so what if so so this is n is there, so we have to define it in, okay, let's define another time. Let's say it is ts, okay. Actually that is not the sampling time, okay, ts is not the sampling time, okay. Okay, let's say it is tn, the time related with n, okay, right, time related to this n, tn, time related to this n, I could get it as tn, okay. So tn is equal to, you know, that n multiplied by t TS, no? Can you remember? Here, this one, N is equal to NTS. Okay, so I used here Tn because the time related with this sample. Okay, I hope you can understand. Okay, because if you put N there, N is get as a T. Okay, but it is not correct, no? There is a time related with N, so we have to take that time. Okay, so let's see. Okay, please try to understand after the session. Okay, if you can't completely understand, please go through this. Still, anyway, we will try to write the program. Okay, let's see whether it is okay or not. Okay, so I defined it like this: Tn is equal to N by Ts, no, by Ts. Okay, but Ts is not defined as what is Ts. Let's define it here. Ts is nothing by 1 by Fs, no, 1 by Fs. Okay, if you put 1 by Fs instead of this Ts, it is okay. But I put like this for more understandable, more interpretable, I hope. Okay, so can you, I hope you get it. Okay, now I put this Tn here. Now that is time related with the sample. So you can see the N value is there, no? N is also there. But NTS is there, so I have to use here the normal frequency, no? Am I right? Because this T, okay. So I write this again here. So here it is cos 25 ft. Okay. So instead of ft, okay, I put Tn here. That Tn is equal to NTS, no? Okay. So it is cos 25f NTS. Okay. So the Ts is there. So F by Ts is capital F. Remember, FTS is equal to F. So I get the Fn here. Cos 25 Fn. So I have put simple F here. If I put the capital F here, it will lead to a wrong, no? So I put F here. So if I put F here, I will get cos 25 capital Fn. Okay, this is the statement I want. Okay, so I change. I hope you understand this. Okay, so I put this value, this one, for our normal frequency, not nominal frequency, our F here, because when we multiply it by Tn, here you will have 25 capital F n. Okay, okay, so this 2 will get capital F, this value, okay. So actually I think it is okay. Okay, so so now if I variable xt does not exist, undefined function or variable fs. Sorry, here we will put capital F. Okay, now it is okay, I think. So again, the undefined function or variable fs. Yes. No. Yeah, this should be also capital. Now it is run. Let's see what happened. So still we see the same. Yeah, TS is not defined. Thank you. Okay. So we run this. So still we have the same problem, no? Now I think we have correctly. Sorry. Again, still this N is there, no? So I have to this N should be converted to Tn, no? because still I use that n here, n will be 1, 2, 3. Okay. So now it should be changed. So there, now it should, we should have a change here. Yes. Yes. Now you can see you can see that we can see the wave here, and no, and also we can see some sample. Okay. Sample, because we have put 20 samples. Okay. So 20 samples should be here. Okay. 20 samples should be here, because n is up to 20. So this is our first sample, this is second sample, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, up to 21 should be there. Okay, because 21 sample we selected. 0 to 20 means 21 samples are there. Okay, so what we have to do is we have to take, okay, we have to take this, we have to limit this axis up to this t. Okay, then it is okay. No, if we limit this limit up to this t, then it will be okay. No, okay, so you can limit the so you can give limits to the x-axis. Okay, because now we have the x-axis is up to here. Okay, but if we limit the x-axis up to here, then we will get the full waveform through this space. No, so I will limit this x-axis up to this t value. Okay, because we need only up to this t value. Okay, I hope you understand. Okay, other values we don't need. Okay, so I limit the x-axis, so I can use this command x limit. Okay, so if you need to limit y-axis, you can use y limit. Okay, so you can give the limits here. Okay, so I give the limits, so 0 to 0.06. Okay, so I give limit to 0.06. If you want to limit the y-axis, you can give this y limit command. Okay, but now we no need to give y limit, y-axis limitation. It is enough to limit the x-axis. Okay, let's see what happened. Actually, now we have the scaling problems there. Okay, clone argument is there, so I think this comma is not on it. Let's go to the, I can't remember the, actually normally I don't keep the command in my mind. I always use the limit. I always use the Google. Okay, limit x-axis, MATLAB. Specify a axis limit. Okay, so let's take. Okay, yeah, sorry, it should be like this. No, it should be within bracket. The limit should be put within this square bracket. No, okay, so if you can, I think you can copy this command here, and you can copy and you can paste here. Okay, so actually this is my passion. Okay, normally I don't keep the command in my mind. Okay, I use the Google. It is easy for me because we can just copy and paste. Okay, so I have limit the x-axis here. So let's see what happened. Yeah, now I think it is okay. No. Okay, so what is the problem? Now you can see we have limit the x-axis. Now you can get the you can get the whole signal within this axis, but only 2 sample we can see. Only 2 sample we can see. Other sample is beyond this limit. Okay, The other samples are beyond this limit. We don't care, no, because only we have up to this. Up to here we have the signal. So other samples we no need to care. Okay. So what is the problem here? Okay. So anyway, if you try to reconstruct this signal, what happened? Okay. So this is your signal. Okay. This now it is almost okay. Please wait another 5 minutes. Okay. This is very important message actually. So I get a screen. Okay, I use paint. So you can see, okay. So you can see that, okay. So you can see that we have this. Okay. So this is our signal. Okay. This is our signal. And this is, you can remember this. This is 50 hertz signal, no? So this is 50 hertz signal. You can see it is a 50 hertz signal. It is a 50 hertz signal. Okay. So you get your sampling frequency is 25. So your sampling frequency is 25. So what is happening? Okay. So your signal is 50 hertz. Okay. And you are sampling with 25 hertz. Okay. So that means you select half rate sample, no? Okay. That means within two circle, you get one sample. Okay. If you get one sample here, other sample you will get after two cycle. Okay. So you can see the first sample here. So this is one cycle. This is one cycle up to here. Okay. This is the one cycle. So after one cycle, you will get another sample. After two cycle, no? After two cycle. After two cycle, you will get another one sample. Okay. So what happened? So you will get another sample here. So if you reconstruct the signal, you will get like this. Okay. If you reconstruct the signal, you will not get the sine wave. You will get some DC signal like this. So it is up to 2 volt. So you will get 2 volt DC signal, DC voltage. Is it correct? No, it is not correct. No, it is wrong. Okay, you can't generate the actual sample, actual signal. Okay, you can generate another distorted signal. So what is this effect actually? This is we called aliasing, no? This is we called aliasing. Okay, so what is the solution? Please suggest. What is the solution? Please tell me. I need the feedback. So after 5 minutes, we will stop the session. Okay. And I have a previous recorded session for the composite signal. Then I will upload it also to your LMS. Then you can refer. Okay. Yeah. Very good. You have to use the double sampling rate. Okay. That means your sampling, your frequency should be, okay, your sample frequency at least should be greater than your signal frequency. Okay, but you will see this also will not give you a good output. Okay, this will also not give you a good output. Okay, let's see what happened. Okay, now we can quickly see. Okay, so I use 100 sample. Okay, my sample rate is 100. I use 100. Okay, so I will okay. Okay, now you can see that I have sample here, one here, one here, one here, like this. So I can approximately reconstruct this signal, but also I will get some sawtooth wave, no? I will get a sawtooth wave, not this, not a sine wave. Okay, so if I So you can see that now we have sample here and here, and also here and here. No, now we have sample here, 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 here. So if you construct this, you will get like this, like this, like this. So you will get this kind of signal, sawtooth signal. Okay, but it is somewhat okay. Okay, but check what happened if this is a sine signal. So this is a cos signal, no? That means your there is a phase difference. So I will remove this phase difference. I will put it as 0. Then I will run it. Okay, now see what happened. Now you get the sample here. This one, this one, this one, this one, this one. And if you have a sine signal and you will get and you get double rate, okay, double rate. Can you construct this signal? Can you construct the sine wave? Please give the feedback. Can you reconstruct? What is the signal you will get? Yes, you can't reconstruct because you will get only 0. Okay, so you can see there are no any signals. No, it is just a 0. Okay, so you can see that it is using if we get the double frequency, in some case it is not possible. If you start the sample here, sometime it is quite good, but if you see the sample here, you will get wrong signal. Okay, so when you are doing the sample, please select the maximum sampling rate you can read, you can select. Actually, still the main problem with the signal processing is the sampling. Okay, I just listened to a conference very recently held. Okay, so there is a signal expert. Okay, someone asked a question, what is the main problem in signal processing today we can face? His answer is the sampling problem. Okay, still we can't, sometime maybe high frequency, still we can't sample at a good value. When we are going to reconstruct it, there may be some problem. Okay, so if I use 200 here, okay, 200 here, so now you can see that now you have 4 sample within one cycle. No, 1 2 3 4 sample within one cycle. So again 1 2 3 4 sample. Okay, so you have 4 sample. Okay, now your signal may be quite good. Okay, so if you select 400, you will get 8 sample. No, you will get 8 sample. Now you can see that we have select only 20 samples. Okay, so only 20 samples are there. Okay, but if you want to find more sample, you can increase this number. Okay, you can increase it up to any point. It is okay, because because we have limit the x-axis, so it is get the required number. Okay, so if you put the maximum number here, it is safe because we are not running out of the sampling. Okay, sample point. If it is 20 now, you can see that here we are running out of the sample point. No, still we have another 2 sample here, this one and this one, but here we can't see it. But if you select the maximum sample here, let's say it is 2000, maybe 20,000, anything you can select, no problem. Okay, then you will not run out of the sample. Okay, so try to get a very high frequency. Then you can see that there are different sample. No, so you can reconstruct the signal very well. Okay, so we will stop here because we are running out of time. Okay, so anyway, I hope so I will send this command. I think this is the important one. Okay, I will send this command through chat box. Okay, So you can, okay. So please copy it and please try to understand, and you can write this. So if you have the idea, you can write this in any form, okay? Please try to write in your way, okay? Don't need to copy this command, okay? We are doing everything logically, no? So I think you can construct your own code, okay? So try to construct your own code, okay? So we will stop here, okay? And you can see that also we have it is also somewhat important actually, this one, okay? This one, I hope actually I planned, I think I could complete up to here, okay? But because some problems are there, student problems are there, so we are quickly running out of time, okay? So anyway, please try to do this one, okay? Please try to do this one. I think it is somewhat difficult, okay? Maybe you can't do it by yourself, okay? It is okay. Some of, if you are fluent in MATLAB, maybe some of can do this, okay? But if you haven't done any work previously with MATLAB, this activity may be somewhat hard, okay? So I will record this activity and upload it to the LMS, okay? Not maybe today, tomorrow or day after tomorrow, I will upload this question also. Then you can refer, okay? So we will wind up. Before wind up, do you have any problem? Okay, if you, okay. Thank you, Richie. If you don't have any question, you can leave, okay? So good afternoon and good luck, okay? Thank you.